Welcome to module 10 of object oriented analysis and design. In the last modules 8 and 9, we have been discussing about major elements of object models. We have seen that object models to be designed need to consider 4 major aspects of abstraction, encapsulation, modularity and hierarchy. They relate both to the aspects of design in the system when we talk about abstraction and hierarchy, and they also strongly relate to how the implementation is done and how the code and different modules are organized. We continue on that and would like to conclude today on the elements of object models. And today we will discuss specifically about 3 minor elements. These are useful elements in an object model, but these are not essential. Depending on certain system requirements and the skill of the designer, these elements will be considered. These will include typing, concurrency and persistence. This is the module outline. This will be available on the left of every slide. So, we have just this is just the context of the elements of object model. Just for your recap, we have done the top 4 already, we are doing the bottom 3. So, the first element, minor element that we deal with is called typing. I am sure all of you have done some bit of programming in C or C++ or Java or Python. You would know that whenever you need to use a value or a literal, or whenever you need to use a variable, there are certain types associated with it. So, if I say I am talking about a variable x, then I may not by default know what kind of value does it contain, or if I talk about 2.3, I need to understand that whether it is a floating point number, how many bits it is represented in, and so on. And things really get complex when we talk about objects which is not simple primitive types of values, but they are composition of their collection of several independent value items which we say are properties. So, type is the core concept which defines how should an object behave. So, in formal terms, the typing is the enforcement of the class of an object. So, typing says that if I know the class of the object or if I know the type of the object, then it will make sure that that notion or the conditions or constraints of that class of that type will be enforced whenever the object is used. So, it may not be interchanged for different object types, and if it is interchanged occasionally in some restricted ways, then it will follow certain predefined rules. What in simple terms it means that if I have 2 variables in C, say x representing an integer variable which will contain an integer value, and p representing a pointer to character which will probably mean a C string, then we cannot use them usually in interchangeable manner. I can use the integer value to add another integer value to it, but if I have a pointer, I cannot take another pointer and add these 2 pointers. But again, I can take an integer and add to a pointer. So, all these different restrictions of behavior will be derived and imposed based on the type of the object. So, just to give you the background, and we will not have enough time to talk about this in depth, type basically derives from the theory of ADTs or abstract data types, and this is a kind of development in programming systems which happened quite before the object oriented paradigm became dominant, which abstract data types have to say that if you are talking about any type, then you basically have 3 different components that you need to deal with. So, for an ADT, you talk about a domain, of values, you talk about operations and you talk about what is known as axioms. So, domains say the whole set of values that a variable of a certain type can take. So, if I am talking about say a 1 byte unsigned integer, then the domain is the set of values going from 0 through to 255. Operations say what can I do with that value. So, we know if we are talking about integers, then I can add the integer, I can multiply integer and so on. But when I add, the operation has very specific meaning. For example, if I am working only with 1 byte unsigned integer, then if the result of addition of two such integers happen to be more than 255, then certainly my domain cannot support that, I cannot hold that value, and we kind of say that we have an overflow and the values wrap around. So, if I add 1 with 255, that is the largest possible value in 1 byte unsigned, then the result is not 256, but the result becomes 0. So, these are the kind of different operations which are defined, and then finally, axioms say that how these different operations interplay between themselves. For example, if I add 1 to an integer, such kind of unsigned 1 byte integer, if I add 1 to it and then if I subtract 1 from it, then I should get back the original result. So, an axiom could be of the form that x plus 1 minus 1 should give me x. Now, if you will understand that if the immediate example I talked about, if I am adding 255 with 1, that is if the value of x is 1 is 255, then x plus 1 will become 0 by the use of overflow. Now, when I subtract 1 from 0, the value should become 255 by the underflow rule. So, this is the overflow rule, this will affect the underflow rule. Unless these rules are symmetric, this axiom will not hold good. It may be that the overflow is allowed, but underflow simply does not change the value, then this axiom will fail. So, abstract data typing is the notion which tells you more on theoretical formal terms as to how should a type operate, and over the years this has been used in several design of several programming languages, but it has become less and less directly usable for the programmers, because we have evolved the mechanism of object oriented programming, where the use of the abstract data types or typing gives a underlying principle, underlying premises on which all these axioms are ensured, and you do not really need to explicitly know or talk about them. So, given that a type is a precise characterization of the structural and behavioral properties, we have seen about these properties, that means basically the attributes and the methods, and it will talk about those properties which all entities of that type will share. And just to clarify that we have been using the notion of class in the same context. In the current course, we will use the type and class interchangeably, though please remain informed that in general in the programming language theory or object oriented theory, they are similar, but not exactly the same, but we will treat them as same in this course. So, this is that very nice cartoon from our OOAD book. You can see that if type mismatches, both of them are 3, but this person is trying hard to fit one shape of 3 into another. So, that is what happens when your types mismatch between variables and you are trying to do something with them. Certainly, several different kinds of types you have been exposed with. Significantly, if you are coming from C and as you move on to C++ or in Java, there are a number of built-in types or primitives types which are given in the language, and then we have certain builders given in the language like struct in C or struct or union in C, or in C++ we have struct, union, class, these different kinds which will allow us to define new user defined types. These are called UDTs, and these are some examples of UDTs For example, in C++, you can make a complex class of complex numbers, which will certainly have different kind of algorithms for addition than the algorithm you use for adding two integers. It will have also new operations like taking the modulus of a complex number and so on. We can have vector types, we can have string types, and if we refer back to our LMS example, these basically are possible from our LMS example, that we could define types or class for executive, for employee, for lead, for leave, for casual leave, and so on. So, these are different kinds of types that we will play out. Now, we would like to take a look into the type of a programming language. This particular heading has a little bit of pun. The use of the word type means kind of programming languages or the data type of programming language. You can interpret it either way. So, typically programming languages are classified into two categories as strongly statically typed or dynamically typed. A statically typed language uses static binding or early binding. A dynamically typed language uses dynamic binding or late binding. In exact simple terms, what it means is just focus into these two statements. When we are talking about type, certainly we have the context is of a variable and a value that resides in the variable. If my language is statically typed, then the type is associated with the variable. So, you say that a variable has a type and that you define at the time of writing the program, and the compiler while compiling determines that this is the type for that variable, and in every context will enforce that type. So, the type is associated with the variable, it happens at the compile time, that is the reason you call it you say the process of verifying type safety of program is based on the analysis of the program text, that is the compiler is working, no data is there, and that therefore, it is a statically typed one. So, if I look into this simple example of C, you all would know, if I define two variables I val of integer type, d val of the double type, then the type is associated with these variables. So, when I start doing certain things that I should probably not be doing, I take a double value and try to put to I val, the type of the variable is still held on to be of integer. So, what it does, the compiler, to make this assignment possible, it could have done two things. One is it could have disallowed it, some languages will exactly disallow that, or some languages like C or C++ will allow implicit conversion. It will take 3.6 as a double value, knowing that I val is int, will make a conversion which in this case will be a truncation. 3.6, the 0.6 part will be just thrown away, and 3 will actually get assigned to the I val. Similar thing will happen if I do the other thing, 2 will become 2.0 when assigned to d val. In contrast, if I use a dynamically typed language, the nature of the code is very similar, it is only that the code is written in Python, and the important omission is all these preceding predefined types for the variable names. Now, we do not provide any. So, what we say is the type now is associated with the value. So, it is not determined at the time of compilation, it is determined at the time of execution, at the dynamic time. So, you look at the value being 2, you infer that that value is of an int type, and since you are assigning that to I val, so you infer that this is of int type, and since you are making this assignment, you infer this int type on this I val. So, you say I val is int, but at a later point of time, say in here. So, these are all sequence of instructions in Python. So, at a later point of time, I choose to assign 3.6. 3.6 naturally has a type which is double or floating point. So, what will happen when I make this assignment? This type is put to I val. So, I val becomes a double type variable, and this is not restricted to primitive types alone. This will also extend to the different user defined types that Python allows, the different Python classes. So, the type of a variable in Python is the type of the value that was last assigned to that variable, and that type is maintained. So, that is the difference in these two statements. Here in static case it is associated with the variable, in the dynamic case it is associated with the values. So, that is the basic difference between dynamic and static, and that gives rise to a lot of consequences, because if you can statically type a language, then the advantage that you get is you can at compile time you can say that, well, this probably is wrong, this probably is a wrong assignment, or this probably is a wrong invocation. In contrast, if it is dynamically typed, you cannot say that, but when we are going to use different kinds of objects moving around, different kinds of objects on different hierarchies. If you recall the vehicle hierarchy we talked of earlier, a vehicle could be land, water, air, a land vehicle could be car or bus. Now, if I just get an instance of a vehicle, I may not exactly know whether it is a car or a shape, or it is an aeroplane, or what it actually is. So, it may be very difficult to conclude at the static time to decide what kind of operations I should allow. If it is a car, I should ask for how many wheels it has, but if it is a shape, I should allow how many different parts does it propeller have, and so on. So, there is always a trade off between whether I want to do static typing for better program safety, or I want to do dynamic typing for better flexibility and more object orientation. So, what happens if we try to look into the more common languages that we intend to use? C is certainly strong statically typed, everything is done at a static time. So, is C++ and Java, but C++ and Java also support part of dynamic typing through a mechanism called polymorphism, and as we will see, that will become a very strong handle to support object orientation. So, C++, Java as a language is grossly statically typed, but they also support some dynamic typing, whereas if you look at languages like Python, they are only dynamically typed, there is no static typing in Python. So, this is one way to look at the programming languages, and I am trying to relate this minor typing element of object models to the language characteristic, because when you finally at the end of the design, when you choose your programming language, the OOP programming language, and want to convert your design, your classes, the hierarchies and encapsulations into that language code, you will need to understand what kind of support you can get from the language. There is another kind of typing or classification of programming languages that is commonly studied. This is between strongly typed, weakly typed and untyped. The strongly typed language say that anything that you use that must have a type, and that type must be a very strict one. So, typing errors will get prevented at runtime, because you only allow things to happen if the type is completely known and can be completely deduced. You do not allow, or allow very little implicit conversion. So, you would not kind of allow in double to be used in place of an int and so on, thereby making sure that you are always using the value of a correct type in the place of a correct usage. And so, certainly strong typing often cannot use static typing mechanisms, because statically you may not know the type of a value all the time. So, as it turns out that languages like Python have very strong typing. C also is principled after strong typing, but as you understand, C subsumes I am sorry, C++ has strong typing, and but C++ also subsumes the whole of C, which is weakly typed. It has plenty of scope for implicit conversion. It explicitly has provided void star kind of pointer, that is pointer with no type, to take care of different specific programming situations. So, those actually make C++ also weakly typed, where you can do things that you could do in C, but if you make a guideline, if you make a policy at your personal level or at an organizational level, that you will only use the pure form of C++, the object oriented and strongly typed part of C++. You will still be able to do all the programming, but of course, you will need some skill as to use that, and you will have to drop all the weakly typed paradigms that C offers you by default. So, these are the two basic different categories, and of course, there is a third category of programming languages which are untyped. That is where you do not need to, you do not specify the type of an value ever till you use it. At the time of using it, you will say that this is the type, and so the type significantly does not remain in the program, it remains in the mind of the programmer. So, these are more difficult languages to program in, and we will not expect typically an object oriented system to be coded in these. The example is any kind of assembly language. If for all those who know assembly languages, you will understand, if you are working in assembly languages, you are directly dealing with bit patterns, and therefore, there is no specific type which is known. So, but this is I am just including these untyped languages as a for completeness. We will typically not make references to this. So, given these different kinds of classification of programming languages. So, just we had strongly typed, weakly typed languages, and we had statically typed and dynamically typed languages, and there are different combinations of that. A language can be statically typed and strongly typed, statically typed and weakly typed, and so on. And C++ falls in kind of a mixed boundary, where, as I said, mostly it is statically typed. For polymorphism, it gets dynamically typed. Mostly it is strongly typed, but if you use pure C constructs within C++, then you will tread into the weakly typed territory of C++. The another concept which you just need to start getting aware of in the context of typing is known as polymorphism. Polymorphism, as the name suggests, basically has two parts here. Poly is one part, one word which says many, morph means change. So, polymorphism is basically the mechanism of working with change. So, it exists when dynamic typing interact with inheritance. We talked about inheritance as a part of hierarchy. We just recall, we talked about single inheritance, we talked about multi-level inheritance, and so on. So, when you would like to code those kind of object models into language, you will need the inheritance to be present in the object language. But along with that, if you also have dynamic typing, that is on that inheritance model, if you do not know at the time of compiling what a specific object is, which class does it belong to, then and need to resolve that dynamically, then you will need to make use of dynamic typing, and when you combine these two, you have polymorphism. C++ naturally gives a very strong framework for polymorphism, and so does Java, so that they become very good vehicles for object oriented programming. There are languages which are monomorphic in nature, which does not allow such behavior to be encouraged. They are strongly and statically typed languages. So, to conclude on this part, please remember that polymorphism is a most powerful feature of object oriented programming next to the abstraction. So, if you are now faced with the question of what are the two top features that an object oriented programming language must provide, so that you can realize all the object models easily in them, it will be the number one would be abstraction, which you have already studied, and now you are getting introduced to polymorphism, which is typing at the runtime on an inheritance hierarchy. We will all of you may not fully understand what I am talking of here, but do not get worried. As we go along this course, we will talk about these polymorphic behavior and its use in the object oriented analysis and design further. We want to talk about is concurrency. We will take a break and talk about that.